Hello everybody, hope you guys are doing well. So continuing on our journey, today we will be learning about, we will see OOP fundamentals. We will try to understand why these are important, and then um so nowadays when we are applying for jobs, right, so there is an additional round as well, that is related to OOP fundamentals, right? So it's um, so we need to know certain uh, OOP. So what is OOP? OOP is like a programming style, right? It's a programming paradigm. If you're following certain principles of OOP, then it is called as an object-oriented programming, right? So why OOP? So like first is basically it's asked in like in interviews, right? They will be stressing on this part. So first is for that. Second is basically it helps us to structure our code, right? So structure our code, and by structuring a code is basically when you are writing, right? So for example, if you are so this is your original code, right? So you need to write code in such a way such that it should be easily modifiable, right? So what if you are adding a new feature, right? Suppose if I'm adding a new feature, then it should not happen that because of this feature I have to change all the remaining code as well, right? So the base has to be designed in such a way that easily additionally a new code or new what do you say, if I trying to add new things, it should be you can add it should be easily uh, we can add them easily, right, uh, without any damage to the original code, right? So this is basically why we study OOP, right? Now OOP, this is a language paradigm, right? So if a language follows the rules mentioned here, so it is a language paradigm. So we say this is a language paradigm, right? That means if a language follows these principles, then it is said to be an OOP language, right? So what is OOP? OOP stands for object oriented programming, right? So this is basically object oriented programming. Now there are certain pillars when we are related to OOP, right? For example, there is encapsulation. So there are four main pillars of OOP. So these are four main pillars. This is encapsulation, then you have abstraction, then you have inheritance, and then polymorphism, right? So we'll see each one of them uh, as we go on, right? So first is like what is an object, right? And what is the difference between an object and uh, so what is an object? Object is like a blueprint, right? So what is an object? So basically, whenever we deal with object, right, there are two things that come across. One is a class, and then second is basically an object, right? So class is like the blueprint that we are going to make. So this is the blueprint that we are going to make, and then the moment when we actually create an object, uh, the moment when we actually create an object, that is basically the moment we actually build the model is nothing but it is called as an object, right? For example, a house, right? So initially the architect will have a blueprint. So suppose we are making an house over here. So this is the blueprint, right? So this is the blueprint. So this blueprint is nothing but my what do you say, the class, right? So this is nothing but the class. Now when the actual construction starts and we actually make the physical house, we say that we are going to construct it from this blueprint itself, right? So this is the object, the actual realization, the actual realization or representation is what is called as uh, the actual realization slash representation is the blueprint, is the object. Okay, now further, so based on languages, right? The class is generally defined by the class keyword, right? So if you are making a class, you'll be having a class keyword over here. And then what does a class consist of? A class will consist of uh, two major things. One is methods. So functions in when you're writing in OP, it's called as methods, and variables are called as class properties, right? So you have properties over here. So you need to write the class keyword. Okay. And then you have methods and properties, right? So why methods? Reason being these are properties because these are going to be attached to this class, right? So hence we say that these are properties, not variables, because it is attached to this class. Now the way you create an object is basically using the new keyword, right? So you write new, and then there is the class name, right? And then class name, and then you call it like this way. So this is like the very basic way or basic structure of how you can implement a class, right? Okay, now let's see. Let's code in some different languages to see, and then like we can see, or we can write it in various other languages to take that feel. Okay, so what we are going to do is just add a new file, say new dot. So then this is Python file, right? So do class, and then this is say Python 1, and then you define say attributes, right? So you say okay, so let's say let's only have this print hello. Okay, and the thing is we want this to be indented inside the block. So expected, oh, just to be, now there is that in it, right? We'll see that later on, but right now we will only call this thing. So you can do a new, so you can say variable name, right? So let's just say variable is equal to new, and then let's just call this class. Now statements must be, oh, I'm outside of this, right? So you have a semicolon here. The way now it depends like on how which language. I guess you have to use the new keyword here. Oh, so yeah, here you don't have the new keyword, just call the class. So you say we are just going to call it this way, and then so this is basically how we write. Just run this thing. Yeah, you have the hello world class, right? So now, okay, now that new keyword is, I know where it is coming from. So in some languages like Python, this new is inferred because Python is heavily overly, in Python everything is an object, right? So in Python everything is an object, so there is no need to add. But in Java, you will have to use this new word. So this is very specific when you're using Java, right? You will have to have this new thing running. So let's see that as well. Okay, so let's do new dot Java, and this is public. Okay, I guess bad name for let's rename it to something. So this is test.java. So now this is that test class that is coming. But let's get rid of that. We can do test, and then here we can have public. Add a token test class expected. Okay, so let's say this is class test, and now let's create a new class here. So we can do class test one, something like that. And let's say this is test one, and then here we don't have void main, we just have a public method over here. So let's say this is public, let's say return type, and say this is now test is never used because you haven't created the object, right? So if I come here inside this, I'm going to do new, so just calling this thing, and isn't this called over here? I guess, yeah. So I have hello world which is coming here, and let's say this is hello world 3. You might say, where is this object being created? So the moment I run this, right, this class is the thing which has main, right? That is automatically, that object is automatically created. If you see, there should be a, okay, it's saying test, but this is already, but the reason is this already gets created by the moment you name this thing, right? That naming, that creation happens. What happened? Yeah, so then the moment you name this as test one, it will automatically be called, and then so you have test, and then so this and this file name needs to be the same because this object has to be created, right? So basically we saw this is how it's in Python. You just call it, and then so if I do console log of variable, right, or if I do print variable, and if I just run this, yeah, see, it's giving me something like main. It's giving an object at this specific location. Okay, now one more. Now what's the difference between an object and a normal variable, right? Okay, so let's say that let's see a little bit about how memory is divided, right? So basically, if you have a memory, you have two parts, right? You have the stack, and then the second one that you have is the heap, right? Okay, so what is going to happen is, so the moment you run, right, basically, so why did we separate it out or split it this way? There is an issue, right? On, so the data will be in the RAM, right? Moment you, so initially it will be in the HDD or whatever your disk drive, right? Basically that could be an HDD drive or HDD drive, however whatever you are using, right? It can be an HDD or it can be an HDD drive as well, depending upon what you are using. So from there the data is going to be called, right? So once you call it, so once you like run the thing, right, so the OS is going to make it in the process phase, and then it's going to be in the RAM, right? So remember, ultimately the CPU has to execute the RAM. The RAM cannot the CPU cannot directly go to SSD because it is way less speed, right? This is operating at microseconds, and this is at a very slow rate. Read write cycles are at a very slow rate. So hence, and we don't want, our goal is to optimize the CPU usage, right? So if you do this, then the CPU usage is going to get wasted. So instead what we do is we put the, once the process is ready, we put in the RAM. The RAM has two buses, right? One is the address bus and the data bus, right? Now this, to execute on the CPU, the data from this RAM has to be copied onto the on-chip data registers, right? So on-chip you may be having certain amount of registers, right? So data is going to get then copied on these registers, and CPU is going to read and write from these registers, because even the RAM is a bit less, as there is some sort of time which is going to be gone here, right? So now the problem is this CPU registers are very small. Now this address bus in most processors it is very big, right? So CPU has on-chip registers, right? This RAM much faster than the external drive. On-chip registers are much faster than the RAM, but they are smaller in size, right? So that is the whole problem, right? Now we'll see what is address bus. So address bus, so basically as I was saying, address bus is generally 20 bit, right? That means it can generate 2 to the power 20 addresses, right? Now data, so to access the data, first we need the address, right? That means if we have 2 power 20 what is it, if the address bus is 22 is 20 bit, then we can access 2 power 20 locations, right? Now the problem is the data bus in most is half of it, right? That means, so if I do 2 power 20, that gives me 1 MB access, right? So in one cycle I should be able to access 1 MB, right? But the database is small, right? The database is so the data bus that carries the data is mapped to the on-chip registers, right? The on-chip registers are not 1 MB or not 2 power 20. Instead they are smaller in size. They are generally 8 bit, right? So that means if I have to take a 20 bit number, I have to do 2 cycles, right? So I'm wasting some CPU cycles and just getting the data. So instead what we do is, the solution for this is we kind of do something called as segmentation. We don't actually this is a virtual concept. We don't have something like segmentation in the memory. The memory is one unified block, right? Irrespective of RAM or ROM, whatever it is, irrespective of hard drive or external drive, it is just one unit block. But what we do is, we to utilize that one CPU cycle thing, right? We divide memory into different segments, and then instead of giving the actual address, we generate something called as the physical virtual address, right? So the physical address is the actual address. We don't use the actual address. We generate something called as the virtual address. Now we divide these, segmentation is basically dividing memory into different blocks, right? So you have different blocks. So first is basically something called a segment block, then you have code block, then you have heap memory. Now every block has a certain characteristic, right? The and then you have a stack, right? The stack is limited in size. It can grow up or down, but it is limited in size, right? So it's limited in size. Like every memory has a certain restriction. The heap, on the other hand, is basically something which is dynamic, right? This is dynamic in size, can grow both upward and upward. Now the programming language internally has to, since the memory is not one, since what we are going to access is not the actual memory, instead it's going to be the virtual or the physical memory. Sorry, it's going to be the virtual memory, not the physical memory. So since the virtual memory is having different blocks, our languages or the thing which we code also should be able to, or should be compatible with this virtual memory, right? So instead of having one unified block, we should have different blocks of data, right? For this purpose only, we don't have one unified memory. Instead, Instead we have something called as different spaces, right? So hence I said we have two spaces. The major categorization is heap. There are other heap, and then the other one is the stack, right? The advantage of heap is it is dynamically allocated. It can grow. The disadvantage, I mean, it can grow both outward and inward. So overfilling the heap is not an issue, right? But then and it is in the memory till it is not needed, right? Now the other memory or the other type of memory that we have is basically something called as the other memory that we have is something called as stack, right? Now the problem with stack memory is stack is limited, and all function call, and then the moment the since it's limited, right, the moment its use is done, it is popped out from the stack. So hence, but the only why objects are really stored in heap is first is dynamic behavior, second is ample size, third is basically till we do not need them, till like we go and we don't do the garbage collection, it is going to be there in the memory itself. However, stack is not that way. Once the execution is completed, everything is thrown out from the stack. Now in previous languages like C and C++, there is something called as calloc and malloc, right? Now even these were stored in the heap, right? But they are different from objects. The different being is in calloc and malloc, when we have pointers. So we have pointers present here. Now when we do objects, right? So basically this calloc and malloc just allocates a block. This only allocates a block. Now when we do object, or when we do an object creation in the heap, right, what are we going to do? We are going to, now we said that the object is the actual realization of a class, right? And a class has two major things, an attribute and methods, right? So what we are going to do is objects will allocate memory to both the attribute. So this is the object, right? So the memory space will be like the attribute and the method, right? And we will have the reference to this method. So what is returned is the reference. Your pointer is returned. This pointer basically contains the starting block, the starting address of this block, like where this address has been stored. Now if you see, even though the memory is a one physical block, right, we say that we have one big block, it may so happen that the because we are using virtual, so we do not allocate, like, so we say okay, let's allocate this entire, no, it doesn't have, the allocation does not happen in a very contiguous manner. Whatever is, suppose if there is some data here and then there is no data in this block and then there is again data here, so this space is free, right? So even here some or the other thing will come. So the memory allocation is not like a continuous or a contiguous sequence of blocks as we think, right? It is the moment we have an empty space in RAM, some or the other thing data will be stored. Now it might be there is other methods as well, right? You have pagination as well, like something like uh, have the current page and then retrieve the old data. So this is something like, these are some techniques, right? So never assume that we are storing everything in a contiguous, even though the memory physically appears like it's a contiguous or a rectangular shaped block. The storage does not happen in a very contiguous manner. It is just random. We cannot determine or which specific address will have what data. And more on that, so and we do not use the exact physical thing, we are going to use the virtual model, right? So all our data is going to be based on this virtual model thing. This virtual model is going to be mapped to a physical address, right? The advantage of having this virtual thing is making sure that we are utilizing our registers in full, or we are not wasting any CPU cycles just to fetch data, right? CPU has other important works as well. Our always goal is basically to make sure that CPU is working all the time, right? Something or the other it keeps on doing in the background. So we do not want to waste. This is a very valuable resource. Can't waste this. So then, yeah. So hence we do this segment. This segmentation is done just to make sure that when we are on chip the registers are smaller in size. So instead of wasting multiple cycles here, we don't want multiple cycles to be wasted, and we just want the data to be read in one single cycle, right? So this is a very good advantage. We want the data to be what do you say, one data to be in one single cycle. This is a very good way of so hence we have something called as or hence we do something called as segmentation, right? Just to avoid this just to avoid that, right? Okay. And yeah, so even in calloc and malloc we do something called as we are in the heap, but the only difference is this heap is this will only give us, first of all, it returns pointers. So pointers are pointing to the starting address, and the only job is it allocates a block, just give it a block. But when you do it, like when we say about objects, now this is not true for objects. Instead, what happens for objects is we create a reference. We have a reference for the block, and what the so the block returns a reference, and it is allocating memory to the attributes and the method present inside it. Why we don't use stack is, first, it's limited in size. Second thing is the by default behavior is things are taken out from the stack. So this is like once the work is done it will be removed. However, the only thing is this removed, but with CPU it is not that, but with heap it's not that way. The memory, or with objects, it's not that way. It is going to be in memory until we don't go and do the garbage collection, until and unless we don't start or we don't do garbage collection, this is not going to be removed from the memory. Okay, so yeah, I guess this is a very good introduction about memory, a little bit about class, and why we had to go towards OOP. Like, why, first of all, why need to add? Because of that, we wanted some way to use the heap. As stack was push in and push out behavior, right? The moment it is done, it's been taken out of from the stack. So yeah, I guess this is all for the session. I hope you guys liked it. I will see you guys in another one. Till that time, take care. Bye bye.